I grew up in Tasmania. I spent a lot of time on fishing boats and on the sea and in the sea. My family was very much a marine orientated family, and so I was always going to end up in something to do with the ocean. I'm halfway through a PhD at the University of Tasmania in the Institute for Marine and Antarctic Studies. For the first year and a half I've been working on ways to better view these small microscopic plants, phytoplankton, from satellites that spin around the Earth from space. So we have these satellites that image the ocean and they measure the colour of the ocean. This colour really comes from the colour of the plants that live in the water. These plants are microscopic. We can't see them with the naked eye. They're tiny little things, and there may be millions of them in the palm of your hand. You scoop up some water in the ocean and there are hundreds of thousands of individual plants there that you really can't see, even though that there's so many there. They're found all over the globe. Any body of water pretty much has these little guys living in there, producing oxygen and helping to sustain our life. And almost 50% of the air we breathe comes from the ocean, and it comes from these little microscopic plants, these little phytoplankton. So if you take a breath and you take the second breath, that second breath has come from the ocean. From satellite we can look at some really broad scale things, and then from the in situ measurements, from the measurements we take in the field, we can get a handle on the very small scale things. And part of my project is to try and reconcile those two things, to try and combine broad scale changes with small scale changes and look at how the ecosystem functions on that really fundamental level. The Southern Ocean is circumpolar. It encompasses the entire world in the Southern Hemisphere. It joins the Atlantic, the Pacific and the Indian Oceans together. This is unique. This is somewhere we don't find anywhere in the rest of the world. During the winter it's completely dark. During the summer it becomes almost completely light. To live in these conditions, things like the microscopic plants, our phytoplankton, really need to be highly specialised and highly adapted. With our changing climate, we can see that the places we will first notice these changes really are in the extremes, in the Southern Ocean and Antarctica. And so a lot of my work is involved with trying to build up our level of knowledge of how that system works. Lynchpin is really unique. It really revolves around trying to communicate the importance of the ocean in our everyday lives and trying to do that in new and exciting ways. Part of the work that I'm doing as a Lynchpin scholar is to communicate with a composer, an artist, and to communicate this importance of the oceans out through a medium that is not necessarily traditionally been associated with science. Lynchpin has impacted the way I think about the importance of my science and also the audience. When you train as a scientist, your audience really tends to be focused towards other scientists and towards the scientific community, not towards the general public. And yet, realistically, scientists have a really core obligation to communicate their knowledge and understanding of nature back to the community. And often it's hard to do that when you've had this really focused training on communication. And so one of the core lessons I've learned, I guess, from Lynchpin is that there is a broader interest in what I do. There's a broader interest in how nature works and how the oceans work, and that it's important to get that message across, and that there are other avenues to do that.